Question number 8. Use compasses and a ruler only to construct a perpendicular bisector of the line PQ that you see below. You must show all your construction lines. Now this is going to be quite difficult because this application doesn't have the ability to draw perfect circles, certainly not use a pair of compasses, but hopefully my multicolored sketches will give you the general idea of what's going on here. So in terms of bisectors, both a perpendicular bisector and an angle bisector require us basically to create a rhombus. If we create a rhombus, it has the unique property of having a line of symmetry, and that then allows us to do one of two things: either cut this line in half in 90 degrees, or in the case of an angle, cut it in half. Now the property of symmetry not only helps us find the rhombus in terms of cutting it in half, but it's also 90 degrees, so that kind of takes care of the perpendicular bit here. So what do I mean by a rhombus? Well, what we do is we set our pair of compasses to a length that is somewhere between the rough middle and 80%, 90%. In fact, truth be told, we set it to roughly 3/4 of the length of this line here. So say that length. I would set my compasses to being that wide. So if this is one end of the compass, this looks horrible, but bear with me. This would be the pencil tip there. Okay, so the pointy bit is in here, and then the pencil would go to there. I'm then going to create an arc like so, which basically tells me all the points that are this red line so far away, this measurement here. Now what that does is, if we're on this side here, that arc basically allows us to give us something like that, okay? Which, when we do the same on the other side, gives us the means to finding these 2 points in the middle of our rhombus. So, using our pair of compasses, a horrible drawing there, and a point, your construction line is going to look like something like this. Your circle, your arc even, come down something like that, okay, where the point was here, and obviously the pencil is what's made the marking on the page. You do the exact same thing on the other side. Point here, don't change the length of it, the pair of compasses have to remain the same, and you'll end up with something like this. Now I'm not going to go down as this being the most accurate thing you've ever seen, but hopefully it gives you the gist of what's coming next. Our line of symmetry, or a rhombus, these two corners effectively are the top two corners of our rhombus, and the 2 points that we started with, P and Q, are our left and right here. Because we kept our pair of compasses set at the same length, this, and this are all the same length, which is what makes a rhombus. Obviously, another way of looking at it is a rhombus is a squint square. And from that, if we draw, I should have really done this straight line thing. If we draw a straight line that passes through those, you will end up with a perpendicular line that bisects PQ, cuts it in half. Now again, mine doesn't look completely accurate, but that looks pretty close to a right angle given how freehand I drew it. So the actual answer itself is this line that we're drawing. The construction lines in red and green are what allow us to find the other two corners, or the two vertices of this rhombus that we're drawing. And of course those blue lines I just added here were for effect, just to show you where the rhombus is. So that is a perpendicular bisector. Done.